Hello, this is the Generally Approachable Sudoku for the 23rd of March 2024. It is Outside Sudoku by Bill Murphy with clues. I think you guys can just barely see them on screen right now. Yeah, the bottom ones and the ones on the sides, they're just barely visible. So hopefully that should be fine. So let's take a look at the rules. Normal Sudoku rules apply. Clues, so place the digits 1 to 9 every row, every column, and every 3x3 box. Clues outside the grid give the digits that must appear in the first 3 cells seen from the clue in any order. So, for example, this 1, 2, 3 clue here means that those 3 digits must be 1, 2, and 3 in some order. These 3 digits must be 5, 7, and 8 in some order, and so on and so forth for the rest of these clues. So yeah, those are all the rules. With that, let us just begin solving. And I think I'll start with the most obvious thing to do, which is just to pencil mark this in. This has to be a 1, 2, 3 triple, because they have to contain the digits 1, 2, and 3, and so on and so forth. We actually do quite a lot with this, as you'll see later on, by pointing triples, which is a technique that is also used in regular Sudoku. So let me just quickly put them in. And now we begin doing the things. So pointing triples refer to triples that sort of point in a certain direction. For example, this triple points along this column into that cell. And so since this triple contains 1, 2, and 3, it points into this cell, which can no longer be 2 or 3. It must therefore be a 4. This also works in every column, and boxes as well are also considered pointing triples. So for example, that triple over here sort of points to the remaining cells in the box and say that none of those cells can be 6, 7, or 8. So we can use that to our advantage here. That cell can be 3 or 4, so it's a 1. That cell can be 1 or 4, so it's a 2. And that cell can be 1 or 2, so it's a 3. Oh, 3 in the corner. Wow, early 3 in the corner. Nice. Okay, we can keep moving here. This 5, 6, 7 point at that, so that must be 8. This cell can be 7 or 8, so it must be 5. This cell can be 5 or 8, so it must be 6. And that cell up there can be 5 or 6, so it must be 7. Alright, can we keep doing things here? I think we should be able to. Right, that can be 8, and that can be 3. That can be 6, that can be 1. This can be 2, it can be 2 or 3. Wow, I didn't even see that. This can be 2 or 3, so it's 9. Why doesn't that work for the rest? I guess it's not symmetrical then. You can't do the same thing on the rest of these. This can't be a 1. And that's basically it, apparently. Okay. We can also put the remaining triples in the rest of these boxes. So let's do that. This triple has to be 3, 7, and 9. This triple has to be 4, 8, 9, I think. Interesting. We can do stuff with that. This has to be 1, 5, 9. Well, this is actually like a cool exercise for you to just spot triples all over the place. This has to be 2, 6, 9. Nice. Alright, so let's keep moving here. We got a lot more pointing pairs to go, pointing triples to go. Normally it comes in the form of pointing pairs because pairs are a lot more common than triples. But here we do a lot of triples as well. This can be 8 or 9, so it's just a 3, which resolves the rest of this. This 1, 5, 9 looks at that. That cannot be 1, 5, or 9 anymore, so that's a 7, which resolves the rest of this. 2, 6, 9 here means that is a 1, which also resolves the rest of this. And this 3, 7, 9 removes 2 from that cell. It removes 3 from that cell, so that's a 2. That's a 3. And we can probably keep going from here. That's a 1. That's a 2. This can no longer be 1, but I don't think that's very helpful. This can't be 9. What else can we do? This can't be 6 because of a pointing pair up here. Oh, this 2, 3 also look at that cell, so that cannot be 2. It's a 6. This can't be 9 because of the triple here, so it must be just a 2. 9 goes here. This can't be 9 anymore. Sorry, 5, 8 means that can't be 8. I think I'm just going in sort of random order here. I'm just kind of looking around to see what I can do, but not going in any certain order. This 4, 8, 9 looks at that cell, so that cannot be a 9 anymore. I think we'll do this slowly. Yeah, 7 here means that can't be a 7. It also cannot be a 9, so it must be a 3, which resolves the rest of this triple. This can't be 9 anymore. This can't be 4 because of the 1, 4 here. So that gives us a chocolate teapot, which I guess I should just explain, is when you have a triple here, but from each triple, from each cell, one digit is removed, which are all different, so it leads to like the 3 different permutations of those 3 digits. And from this state, you cannot deduce anything at all, so yeah, that's why it's called a chocolate teapot. It basically does nothing for you. It's like a teapot that melts when you pour tea in it. Can we do anything else though? This 3 resolves this 2-3 pair. This 7 resolves this 7-8 pair. 5-6 means that can't be a 5. So there's another chocolate teapot right here, which hopefully is actually a chocolate teapot, not just something I'm missing. Oh well. Yes, 1 here resolves this 1-4 pair. 5-8 here is not resolved yet, but we can work on more triples here. So this triple has to be 5, 3, 5, and 8. While this triple has to be 5, 7, and 8. And this can't be 3 or 8. So it must be just a 5, which probably resolves everything, right? 8 goes here, 5 goes there. This must be 3. Oh no, a 7-8 pair here is resolved by this 8 up there. So once again, the 8 comes to rescue. Now that's a pair, which has to be 2 and 4, I think. Yeah, can't resolve that yet. I can't just say I really love the font. I think this font is very common. I don't remember where the font actually is, but I love this font so much. I don't know why. It looks so squished down to me for some reason. Yes, this 9 here resolves the remaining triple over here. Which, once we have... yeah, the cool thing about this kind of chocolate teapot is that once you resolve one of them, the rest is also resolved. You can also pull that off in a lot of other places as well, but chocolate teapots are confirmed if you resolve one, you resolve the rest. Did I repeat a digit here? No, I didn't. It's 1-4 remaining, 1 resolves that. So we can place remaining triples here. This has to be 5, 6, and 8. This has to be 5, 6, and 7. Yes. And because 7 can't be in that cell because of this 7, 7 must be here. 9 resolves this, which means that this is all resolvable. So we have another pair over here, which has to be 4 and 2, 2, 4. That forms a 2-4 pair here, which is, you know, interesting. This has to be 5, 6, 7, I believe. And that has to be 6, 7, and 1. 1, 6, 7. This cannot be 1 or 6 anymore, so it has to be 7. That resolves this over here. That must be a 1. Those can be 7, and the 6 comes to resolve this once again. Cool. Could do the rest over here, I think. This has to be what, 5 and 8? Yeah. This has to be, well, it forms a triple, I think, because this isn't resolved. So this forms a triple consisting of 3, 4, and 6. While this forms a triple consisting of 2, 3, and 4. Now this digit can't be 2 or 3, so it must just be 4, which removes 4 from this cell and does resolve this for us. 3, 6 pair means that's a 2. I guess this 3 also fixes that for us, and this 3 resolves the remaining 3, 6. Which means what? Don't know what it means, but that's also a triple because in this column, a pair is isolated on its own. It does not affect any of these 3 cells. Well, it does, just that, you know, none of these digits can be in those 3 cells because it's a pair. So the remaining digits here are actually 5, 7, and 9. Yeah, and this 7, 9 resolves this 5. This can't be 7 anymore, so it's a 9. 7 goes down here. 5 resolves this 5, 6. Which, well, this can't be 5 either, so that's an 8. 5 goes down here, which resolves this 5, 8 pair. We're almost done. So just a lot more pairs to go. This has to be 2 and 3, I think, which resolves this. And I think this 2 resolves everything outside. Yep. And we're almost done. Sorry, those digits have to be 4 and 6. Yep. And those last 2 digits are 1 and 8. 1 goes here, 8 goes here. And that solves the puzzle in 8 minutes and 29 seconds. Nice, we're going back to basics here with regular Sudoku tricks, but I think that is you know, quite enjoyable as well. So yeah, I hope you enjoyed this video. I'll see you guys next time. Bye bye.